Hello everyone. Good morning. Okay, I think we can start. So the questions were like super easy. I'm seeing the questions look super easy to me. Okay, so let's see. Hmm, just a second. Hmm. Let me share my screen. Just a second. Okay, just okay. How many of you completed all the questions? Anyone? What's the number? What's the number of question? Then 2, 3, all. 3, all. Okay.
Yes, sir, we did all three, but in the area question, there was one test case failing, sir. The sub-area question, sir.
It's a very question. Let's check.
Sir, the questions were relatively easy. And can you, after this discussion, can you please complete the area subtraction and spiral matrix traversal?
Yes. We'll do that. We'll do that.
Sir, spiral is very important, sir.
Chalo, we'll do spiral as well. Okay. So spiral array subtraction diamond. So we have done. Is there any 2D? 2D arrays. There were questions. So you had asked maxima, minima, and I guess there was one more. Find the path. Yes. So these are the 4 questions that we'll discuss today. Okay. Hmm. We can't print it in optimized in NQ because once you are asked to print it, right? So how can we print something without going through it, right? So that's why it's NQ and there is no way to optimize it. So I'll talk about that. So let's complete these questions first, easy ones, and we'll complete this. Let's take 30 minutes over here to complete all the 3 questions, and then we can jump to this. So see, this contest was easy. That this was the first contest. So like this was to give you idea of how a contest would look like, how your time bound way to approach it, right? So now going forward, right, we'll try to prepare one more difficult questions. Now you're seeing that the difficulty of questions are also increasing. You're getting more good doubts. You're getting doubts in the gym section. The questions in the gym sections are also increasing difficulty, right? So going forward, your contests are also going to be to like labels are going to increase. This one was relatively easy because this was your first contest, obviously, right? We don't want to give you too much of like this. Oh, please don't annotate. I don't have that. I don't see that option in Zoom to stop it. Zoom is very strange, right? It's like sometimes options are there, sometimes it's missing. Very difficult to figure out. Okay, now let's quickly discuss this. Okay, so we have to print this number pyramid. Now, this looks easy. So firstly, we have to run a loop that will run for the number of lines, which is order, which is n, right? So first loop always runs for the number of lines. So we'll run this. Then the second loop will run for the number of values we have to print in each line. So for I equals to 1, we have to print 1 value. I equals to 2, we have to print 2 values. I equals to 3, we have to print 3 values. So J loop is going to run for I line, right? The J loop is going to run from 1 to I, J plus plus. Done. Okay, we got I, we got J. Now what else? So what's the value we want to print? I equals to 1, we are printing 1. I equals to 2, we are just printing 2. I equals to 3, we are just printing 3. So in general, I can say for any I, we're just printing I. And there is also a space. Then okay. And now we printed this. Now what's left? So we are left with spaces. So for I equals to 1, we have 2 spaces. I equals to 2, we have 1 spaces. I equals to 3, we have 0 space. Or in general, we can say we have n minus I spaces. Yes, similar to the other logic that we wrote. And k is equals to 1. K is less than equals to n minus I. K plus plus. And since we have printed 1 space over here, so we just need to make it 2 spaces then. That's it. Which I know I did it very quickly, but I hope. Yeah. I'll not skip because there might be doubts. Someone might have doubts, so I don't know. Someone might be watching the recording, so they might also have doubts. Okay. Sorry. Actually, it's in between of both of them, so I guess so. Complexity here is n square. Yes, it's n square, right? So this is the right. Okay, let's submit it. So these values are in between, so that's why we have printed only 1 space. We don't need the second space, right? If it were aligned to these values, then we would have needed 2 spaces. Okay, done. Okay, so tell me what's any doubts over here? So firstly, we ran a loop for n times, which is printing the number of lines in the pattern, similar as always. Then we printed a loop for I times, which is printing the number of values in each lines. And inside this loop, we are printing I, which is the value that we want to print. For line number 1, we are printing 1. For 2, we are printing 2. For 3, we are printing 3. For 4, we print 4, and so on. Okay. Now, at the end, we are just changing the line. Now one thing was left was printing spaces. So printing spaces here we need to print it in so first line we have only 1 space, second line we have only 2 spaces. This is n minus I space. Okay, that's it. We don't have to print 2 spaces over here, just a single space, and this should be done. Okay. Yes. Clear. Test case field might be somewhere you would have handled +1 -1 over here. Just check once. Okay, I'll share the link. I'll share the code as well, so you can validate this. So you can you'll also have access to this contest on a portal. But what I generally do is I'll create this and share it myself. New project. Save this. This is your contest one, right? March. This is the URL. This is the solution. Okay. Okay, let's go to quickly the second question then. Okay, you can validate this. I'll share you the link of the question and link of the having the solution. So you can validate whether what's the issue in your code. You can retry it in case there was any issue that's coming. Even if it's a single test case, you need to figure that out. Yes. Okay. So now let's look at this question where it is asked to print the second half of array. Right, so this is also easy. Just that it would have like could have asked us to reverse the array, but it just asked us to reverse the second half of the array, not the entire array. Now, how does it define a second half in case of odd and even size of array? So that both the examples are given. If these kind of examples are not given, so you can test it using this input and check what's the expected output. In case of interviews, you can clarify this with the interview. So how do you define second half in case of odd array? Is this the last 2 elements, or is it including this mid element as well? So here it is actually including the mid element. So you can see this is actually putting this at the end, and the first 2 elements are untouched. So for the odd index where it is 5, the mid index is 2, right? mid array's index is 2, which is n by 2, right? So mid element is n by 2. Okay, what's the mid over here in case of even? So we're just reversing the last two things, last two parts, right? Last two numbers. So here also the mid index is 2, which is n by 2, right? In the both the cases, even and odd, the mid index is n by 2. Okay, so understood. How did we get the mid is n by 2 in both the cases? So look here. So we are just reversing these two elements. So in these two elements, what's the index of this mid element? 2, right? So how is it related to n? It is n by 2. Okay. Similarly here, what's the index of the element from where we are reversing? This, which is 2. How is it related to n? It is n by 2. So in both the cases, even and odd cases, it is n by 2. Okay. Now, we have to reverse from n by 2 to n, right? So we have to exchange the value of n by 2 with n by 2. Okay. So let's find out how many elements are there in between, or let's check this. And the easiest way I say is to take two values. Low is equals to mid and high is equals to n minus 1. So this is the first element, this is the last element. Until we have elements, so how do we reverse something? See, the easiest way to reverse is, so let's say this is the array 1, 2, 3, 4, 5. How do you reverse this entire array? The easiest way to reverse is swap these two values. Swap these two values, your array is reversed. Let's check this. So you'll swap these two values, then swap these two values, and then this. Is the array reversed? So swap the first value with the last one, second with the second last, third with the third last, and your array would get reversed. Okay. Now in case of here also, we can do the same logic. It's just that we have to apply it on the half of the array. Okay. So what we can take is, we can take one value, we can store one index over here, one index over here. Let's call it low, let's call it high. Okay. Now what we can do is, we can simply traverse from until low is less than high, we can simply traverse. Okay. And what we want to do is, we want to swap a of low, temp is equals to a of low, a of low is equals to a of high, and a of high is equals to temp. Low minus minus, sorry, low plus plus, high minus minus. Okay, done. Now after this, we have to print it. Okay. Now there are multiple ways to do it. Actually, you can actually try to reverse that array in multiple ways. Right, you can store it in another array, then like from a reverse to a start, like do another kind, like do swapping in some other way to get it reverse. So there can be multiple ways. That's fine. So this is just one of the ways to do it, and I find it is easy as compared to the other ways. Let's run this code. Okay, we got this reversed. Okay. Okay, and now why L plus plus H minus minus? Okay, forget about what is L and what is H, what's the starting and ending value. Let's say we have this loop and we want to reverse this array. Okay, we have this loop. That is also fine. That's fine, but that is only printing in case you are, let's say, asked to return the array, or in case you are asked to actually reverse the array, that won't work, right? That is just printing the array in reverse. That is not actually reversing the array, right? Okay, see, so what we have done over here, so let's say this is the array, right? Let's forget about we are asked to reverse the half of the array. Let's say we are given a full array and we have to reverse that entire array. So how can we reverse this entire array? So what you can do is you can just swap the value of the first with the last, second with the second last, third with the third last, okay, and so on. You'll finally until you like swap all these values, you'll reach to a point where this array is reversed. Okay, so let's say we start with L is equals to here and high is equals to here. So we just swap these two values, and we know how to swap two values in an array, right? If we know the two index, how you can swap? You can temp is equals to AFL, AFL is equals to AFI is equals to temp. We already know the logic of how to swap two values in any given two array index or any two variables. Okay, we just did that. Now these values are swapped. Okay, once these values are swapped, is it done? No, we actually have to swap the other values as well. So we can just move the low to here and high to here. So we simply move the low to 1 ahead, which is low plus plus. We simply move the high to 1 lower, which is high minus minus. Okay. Then, so now you'll see key low is in over here, high is over here, and we have like we have reached to the point where we can swap the second value. Now next iteration is low less than high. Yes, there it is less than high. So we'll swap these two values. So 2 and 4 will get swapped. This same swap logic. And then low will increase to here, high will also decrease to here. Now ultimately at some point they are going to be equal. So this is going to end over here. The loop is going to end because we have swapped all the values and there's nothing left to be swapped. Okay, and finally we get this, which is the reverse of the array. Now just that we have to apply the same logic to reverse it, that we don't need any additional space, we don't need any multiple loops to swap or anything. We just can simply swap it in the same array by doing this, and we just need to start the low with mid and high with n minus 1. That's it, because we are asked to swap the second half of array. Now yes, this logic is going to work for both even and odd sized array, right? So in case of even size, what is going to happen? Let's say, so here we have a odd sized array. In case of even size, what's going to happen? 1 2 3 4 5 6. Okay, so this is going to get swapped with this is going to get swapped with this, and this with this. So low and high, okay, start and end. Then low that two get swapped, so 6 and 1. Then low changes to here, high changes to here. These two get swapped, so 5 and 2. Low changes to here, high changes to here. Then still low is less than high, which is true. So we still swap them, 4 and 3. Now low changes to here, high changes to here. So now low is less than high. This condition doesn't hold, and we exit the loop and we have swapped that. Okay. So this will work for any even odd size array. It is also going to work for any, if you are given, let's say, just not swap the right half of the array. If you are given just reverse the array from index P to index Q. Okay, so you can start your low with index P and high with index Q. That's it. You can just need to run this logic and this step. The complexity is order n. Yes, the complexity is order n. Space wise it is big of 1. So there is no additional space that we are using, and there is no the time wise it's the most efficient logic that we can write. Now if you are given any P to Q, be it like entire array, be it from mid to end, or be it from any two index P to Q, you can use the same logic to swap the array. Okay, simple. So I'll explain you this logic in detail. So there is like this logic has a lot of other use cases, not just like reversing an array. So this is a like small idea of two pointer, of what two pointer is. Right? So this is the two pointer logic, right? So I have talked earlier about what is two pointer logic, right? So this is the two pointer logic. So where we are taking two pointers, right? One pointer at the so these two pointers can be anywhere in the array, right? We have some logic to run. It's just that we have taken two pointers. We call these two variables as the pointers in the array, okay, which are pointing to some index in the array. Now we do some operations on this until we violate a certain condition where we have to stop this loop, and we update these two pointers. Next iteration will do some logic on some to index again. Same logic on some to other index. Same logic on some to other index, and we'll keep on doing it until these two pointers like reach some condition where we have to stop doing this. Okay, that's it. So this is the entire logic. No, you can use a for loop as well. That's like it's not required that you have to always use a while loop. You can use a for loop, move this initialization to there. We do multiple initialization, right? And you can do increment over there. Just that we write it in this way, but you can write it in this way as well. So for example, we can move this. So we saw that we can do multiple initializations inside this. We can have multiple like conditionals like this, and we can do things like L plus plus comma H minus minus term. So this is also fine. But if I write it in this way, it would look a little bit more complicated initially, right? But it's the same thing that I wrote in the while loop, right? Like the pointer is there in C++. That is like, I'm not talking about that pointer. That is completely different. That's not there in Java, right? So this is like a concept in arrays where you want to do certain work. So we take two variables pointing to two index in the array, and that's why we call it as two pointers. Okay. Or you can say it is generally pointing to some index in array, and we are doing some logic on those two index, and then we are updating the pointers. So that's why we call it as two pointers. Sometimes you also require 3 pointers in this. So three variables pointing to three different index. You're doing some logic, and then you call it. So till now also we were using this kind of logic, just that we are not taking three variables. So in case of like when we are finding out geometric progression, so what we did, we wrote three nested loop. So it was giving us three values and we were checking, right? So we could have also taken three pointers instead of three nested loops. So we could have taken I equals to 0, j equals to 1, and k equals to this. And we can increase it in certain ways to until I, j, and k all exhaust. There is a very good implication of this, which is searching a number in the array. Now, till now, if I give you an array and I tell you to search a number, right? So the best thing we can come up with is we can go to the entire array and we can tell whether the number is present or not. That is big O of n. Okay. Now we cannot do optimized searching than this, right, on a normal array when we don't know anything about array. So if you are given an array, you can simply you can simply go through the array and to tell whether it is present in the array or not. There is no way you can violate this. The only way to search is go to the entire array and check whether the number is present or not. But there is another way, right? If the array is sorted, right, then we can do this search operation log n time, and that is using this two pointer concept. What does pointer mean? So pointer simply means this ln h variable that we have taken over here in this case, which is like pointing to two index in the array. Okay. In C++, pointer is a different thing. Okay? This is a different concept. This is a different concept. Pointers, if you're talking about C++, that's a different thing. Okay? So we don't have that in Java, so don't get confused with that. How to swap values without extra variables? Yes. How many of you know this? How to swap any two values without any extra variable? They not cover this in class. No? No swap function. So let me show you then.
Sir,
yes.
Here in this loop, like we are initializing and updating more than one variable. So can we write more than one conditions also in the single for loop?
Actually, conditions have to be changed, right? So condition, if you're at multiple, so you need to use logical and or something like that. There cannot be multiple conditions. It would be a single condition finally, but you can write a like complicated expression like using and or not, all these expressions. Okay.
So we can't use comma condition.
No. So how will that work, right? So like modern day programming, comma is simply equivalent to this or. Okay. So in like the modern compilers, they support comma. So if you see comma somewhere, it is just like writing or. So this is equivalent to writing this. Okay. So or is basically same operation, right? So if you mean comma, what do you want to check? So either you would want the anyone the condition is true, so you want to run the loop, so you can use or for that. If you want all the condition is true and then you want to run the loop, then you have and for that. We already have that two things. Now, if you want to have any such condition, you can write that over here. Okay.
Okay, got it.
Yes, Adnan, that's correct. Almost, yeah. I guess it's correct. So what's the way to swap two values without actually changing it? I can't do it over here. I've erased everything. Let's look over here. See. So let's say you have I is equals to 10 and B is equals to 5. Okay. And you want to swap two values without using a temp. So what you can do is you can write A is equals to A plus B. Okay. What this would do? So what's the value over here that you'll get in A plus B, which is 15. Okay. Now what you can do is B is equals to A minus B. Okay. So what's the value you'll get over here? So current value of A is 15. 15 minus B's value is 5. So 15 minus 5 is 10. Okay. And at the end, you can do simply A is equals to A minus B. So what's the current value of A? A value is 15. 15 minus 10, which is 5. So at the end, what's the final value? If you print A and B, you are going to get 5 and 10. Let's check this. So these are the kind of questions that you get in interviews, right? You know the thing how to do it, but interviewer will be interested in asking something which you will face difficulty to do. Okay. Okay, now here you can replace the addition with multiplication and subtraction with division. Okay, and that would also work fine. Let me change this to some X. Okay, see, we are getting 5 and 10, which is fine, right? Now, like if you replace this with multiplication and this with division, it will still work. So see what you're doing, multiplying A into B, this will give you, earlier it was giving 50, now it's giving to give you 50. Dividing A by B, so A is 50, 50 divided by B, which is 5. So you're going to get 10 for A, 10 for B, right? And again, you do the division. A is 50, B is 10. So 50 divided by 10, which is 5. So you're going to get 5 for A. Now, if you run this, you're still going to get B's value is 10, A value is 5, which is 5. Which is the reverse, right? So either you multiply or you do addition subtraction, both are going to give you the result. Okay, you don't need to remember this logic, you can simply build it up. You just need to know that there is something going on with plus and minus, right? And like I don't remember this actually. So yeah, you can build it up. You just need to know there is some additions that you can do and subtractions that will result in this. Okay, use it a few times, you'll get used to it. There's this thing which you use minus such is called 2 pointers. Yes. So the concept of behind binary search is 2 pointers. Yes, that's it. Okay. Okay, so we're done with this. Now the last question. So we have to find the subarray sum greater than the middle element. Now let's say if we had asked to count the such subarrays or do anything. See. So now if you would have asked to count such subarrays or something, we could have thought of optimization. Now, when you see like what I told you, if you see something like printing the subarrays, then that's n cube, right? No matter whatever you do, the logic is n cube because you are printing the subarrays. Okay. So once you are printing the subarrays, the logic is going to be n cube and you can't optimize it, right? So we can reduce some unnecessary iterations that we'll try, but the logic is finally going to be n cube. And let's check whether n cube is going to be fine. See, n is 100, so n cube should be fine. 10 to the power 6, it should be fine. Okay. So if I go over here, so firstly, how do we print all the subarrays? So we can simply start with I equals to 0, I equals less than n, I plus plus. What is this? This is the start index. How your start index is going to vary. See, this can be your start index, 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 right? What are n square? So basically you would be storing all the index of I, j, and then you will be printing that in n. Yes, so that would also work, n square. Let's check. What is there is some, no, this would be n cube. No, if you print over here, that would be anyways n cube, but yeah, if you store it, additional space additional space can reduce it. Yes, that's correct. Additional space will reduce it, but doing it directly, I don't think there is way. Yeah. I'll show you how additional space will reduce this. I'll show you that as well. Okay, so let's see first. So this is like the start index of start of the subarray. Okay, and then we do this j, which is the end of subarray, right? J is less than n j plus plus. This is the end of the subarray. Okay. Now what we need to do is we need to find out the sum. So we can take a sum which is outside. Okay. How many of you wanted to see? Oh, sorry, let's print all the subarrays. Okay. So someone asked to print all the subarrays. So let's do that. And then you can print all the subarrays. So printing all the subarrays, you need to go from I to j, which is the start of the array, to end of the array. And you just print all the subarrays. System.out.println, or let's say print a of k, which is your subarrays. And then you just change the line. System.out.println. Okay. If I give it this subarray, so it is going to print all this array. It is going to print all the subarrays of it. That like yeah, got it. We can so if you want to print it here, I got this. You can use additional space. That is right, this solution. Yes, I guess probably missing. Why do we see till this spaces print ij. Oh, sorry. This is going to be I plus 1, or this is going to be I, actually not I plus 1. This is going to be I. Run the score. Okay. It will reduce to n square. Yes, that is fine. That would reduce it to n square. Okay. See, so we have like this two loops, which is, and then we are taking this third loop, which is going to like print it. Now this is n cube, right? If you are asked to print all the subarrays, we can't reduce it, right? There is nothing we can do. There is one thing like you can do is you can store all these indexes, start and end, into some array, and then you can iterate through that array to print it. So how many subarrays will you get? So you are going to get, how many subarrays are we going to get? So we are going to get at max as okay, let's figure out how many subarrays do we actually have. For I equals to 1, I don't think that is reducing. I equals to 1, we have n subarrays, right? 1, 2, 3, 4, which is n subarrays. So for first index, we can have n subarrays. For second index, we can have n minus 1. For third index, we have n minus 2. For fourth index, we have n minus 3. For fifth index, we have n minus 4, and so on. For the last index, we'll have 1 subarray. Yes. So these are the total number of subarrays we are going to have. Check for this one, right? I'm telling you about total number of subarrays. Okay. Now all the subarrays is just sum of this. So n plus n minus 1 plus n minus 2 plus n minus 3 up to 1. So how many numbers we have? So have n into, so this sum is n into n plus 1 by 2, which is n square by 2 plus n by 2. These many subarrays we have. N into n plus 1 by 2, right? So you can simply tell it is. So this is n square. So almost order of n square. Okay. Let's check. So 4 into 5 by 2. So it is 4 into 5, 20 by 2, 10 subarrays. We have total 10 subarrays from here. So 1, 1, 2, 1, 2, 3, 4. Sorry, 1, 2, 3, 1, 2, 3, 4, 2, 2, 3, 2, 3, 4, 3, 3, 4, 4. How many subarrays? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. So total number of subarrays that's present in an array is n into n plus 1 by 2. Achha, how many of you understood this? How did we get n into n plus 1 by 2? Or how many of you didn't? So that is also n cube logic. Then there is no way to reduce it, right? That's correct. Yeah. So using space also will not reduce it from n cube. I'll show you how it is not going to reduce it. Okay. ये समझ आया firstly? Yes, no? Doubts? See, देखो, just assume कि for first index, right? First index के लिए we can have n subarrays starting from the first index. How can I say first index has n subarrays? Just look at here. The first index के लिए we are starting with 1. This is one subarray. This is 2. This is 3. This is 4. Right? So it will make one subarray with each of the array element, right? So till each of the subarray, each of the array element. So this is n subarrays in total. For the second index, right? For the second index, for I equals to 2, we can actually make n minus 1 subarray. So this is 1, this is 1, and this is 1. So n minus 2 subarrays, right? Then for third index, we'll make n minus 3 subarrays, right? For 3 index, we'll make n minus 3 subarrays. Yeah. So n minus 2 subarray, right? So on. So n minus 1, n minus 2, n minus 3, and so on up till 1. So the last index will simply make one subarray, which is itself, right? Okay. Now for each, so the like what are the total number of subarrays? It's just the sum of all of these values. So sum of all of these values is n into n plus 1 by 2. Now this is just the sum of all natural numbers, right? Sum of all the natural numbers from 1 to n is n into n plus 1 by 2. Now if you we just validate this, so if the array size is 4, so this result is going to give us 4 into 5 by 2, which is 10. Do we have 10 subarrays here, or do we have more? We wrote all the subarrays and we exactly have 10 subarrays. Okay, and this is going to hold true for any length array. It is going to have n into n plus 1 by 2 subarrays. Okay, understood? Yes. Clear? Okay, so now this is like n cube, right? The using space also will not reduce it. Okay, I just lost it a bit. I'll show you how you using space will still can't reduce it. For 2D array, so 2D array is different, right? So subarray is defined for a single dimension array. For 2D array, it's like for multiple one-dimensional subarray. So each one-dimensional subarray will have n into n plus 1 by 2 subarrays. N minus 1 factorial, I don't think so that is getting multiplied, right? So that is not the number of subarrays. Can we use hash map? So I'll check. I'll talk about the optimization. First, let's find out the solution. So, okay, this is printing all the subarrays. Do we need all of them? No. We need to find out the sum. So sum will find out in the optimal way. What we were doing in order to find out the sum, we took a sum as 0 at the start of each subarray. And every time we are adding a new number to our subarray, we are just adding that value to our sum. Okay. Now, what we have to check is, we have to check whether the sum is equal to some mid element or not, or it has given that the mid element in the array is n by 2, right? So the sum is equals to a of n by 2 for both even and odd. This is only the mid element, right? If it is equal, then we have to print this subarray. If it is not equal, then we'll not be printing this subarray. Okay, that's it. So every time we find out add a new number to the sum. So what we are doing, see, every time we can just use the previous sum. We don't need to find it again. So what we can do is we can just use the previous sum. We can add the new number to it. Okay. And every time we reach that sum equals to n by 2, right? Is it greater than mid? Okay, greater than the middle element. Okay, so this condition will not be equal to this. Sum is greater than this. Or equal to is also there or not. So greater than the middle element. Okay, it's not talked about equals to, it's just talked about the greater. 1 2 3 1 2 3 4 2 3 2 3 4 4 3 4 and 4. Okay, then let's submit this. Now I'll talk about optimization, the things that you can do. Yes. Okay, this passed. Okay, now how many total number of subarrays we are having to have any given n? So the total number of subarrays is n into n plus 1 by 2. That's what we calculated, right? N into n plus 1 by 2. This is the total number of subarrays. Okay. So now see what we are doing over here and why this logic is n cube. See, so this condition, is it always going to be true? No. In the worst case, right? So we say like it's the, if you have a complexity this, we say the worst and the best case. Okay. What's the best case and what's the worst case? So see, so in the best case, let's assume. Okay, sorry. Okay, let's assume in the best case, this condition is never true. Okay, so in the best case, this condition is never true. So what's the complexity we are going to get? So we are going to get this and this, which is big of n square complexity. Yes. Right. In the best case, we are best cases, this condition is never true. So we are going to get simply big of n square. Now, what's the worst case? So this we call as the best case complexity, where we have a condition where this is always true. What's the worst case? This condition is always false. That's the best case. What's the worst case? This condition is always true, right? No matter whatever, sum we are getting, this condition always true. Let's say this is a 0 or something, right? A of mid element is 0. So whatever sum you will find out, or you will always get it true, right? So this is like the worst case, which is big of n cube. Yes, omega and theta are somehow related to the best and worst case, but not in this way. Actually, there is like, I'll talk about that sometime. Okay, not now. I think I'll talk about that in the like class where we'll discuss that. Okay. That is yes, omega and theta is actually related to some of best and worst case, but not in this direct way. Okay, understood how I'm telling this is the best case complexity, this is the worst case. So best case complexity is also like it's a fair complexity, right? We can get n square. This logic might work in n square, but only condition is subject to the condition that this condition is always false, right? And but the worst case complexity that this condition is always true, so we get it as n cube. Now what do we say? So we always consider the worst case. Now we also like you'll also hear about an average case. What is average case? In this scenario, the average case will be like let's say 50-60% of the sums are actually equals to are greater than n by 2, which is like average case 50% of the sums are greater than this. In that situation also you are getting n cube. So that is the average case situation. If this is anytime equal, right? So you get n cube complexity, and that is the average case complexity as well, right? So 50% of cases are true. So that is also the average case. So the like we consider this average or worst case as well always, right? So this is like the n cube complexity that we always consider while telling the time complexity. So this complexity is n cube, okay, in worst case or in the average case. Understood how it is in average case or worst case? So the time complexity is dependent on a if check. Now that if check is true or false, that changes whether we are going to get n square or n cube complexity. Now in average, in the worst case, we are going to get n cube. Only the best case if none of them is satisfied ever. So that is like n square. Okay. Now let's talk about, can we optimize this? So there is no way to optimize this beyond n cube. Okay. For this n cube is complexity is right. Now why am I telling there is no way to optimize this? Let's say, so you can select, for those who try to use additional space, right? So you can okay, can I again explain this part? Okay, so let's understand this, otherwise you won't be able to understand the next part. See, so let's say you are given any sub array, any array, take 1 2 3 4 5. How many sub arrays you can form with starting with 1? So just simple question, forget about everything else. How many sub arrays will be found starting with 1? So 1 1 2 1 2 3 1 2 3 4 1 2 3 4 5. Yes, so 5 sub arrays. Why you are getting 5? Because the length of the array is 5, right? The length of the array is 5. If the length of the array was 6, you would have got 6 sub arrays. Yes, so you're actually getting the length of the array as this, because first iteration this, second this, third this, and so on. So you're going to get n sub arrays starting from the first index. Okay. If I just change the index to the second index, how many sub arrays you are going to get? Starting from here. So starting from here, we are going to get this as the sub array, this. Just that one sub array was removed, right? So we are going to get, just a second. This is class mein. Once it's create a break and print. So yes, so let's see. So we have 2, then 2 2 3 2 3 4 2 3 4 5 2 3 4 5 6, right? So we have all the subarrays that we got from here to here. See this part, right? We got all of them, just that one was missing because one was not part of this. So we got actually n minus 1 subarrays, right? So n minus 1 subarrays starting from 2. Similarly, you'll get n minus 2 subarrays starting from 3, n minus 3 subarrays starting from 4, n minus 4 subarrays starting from 5, and like n 1 subarray starting from 6, and so on. So if you just write it for a general expression, you are going to get n minus 1, n minus 2, n minus 3, n minus 4, up to n. So it is sum of all the numbers from 1 to n, right? Now, what is the sum of all the numbers from 1 to n, right? How do you represent sum of all the numbers from 1 to n? There is a mathematical formula. This we used to study in standard 8, right? What was this? So this is simply n into n plus 1 by 2. That's it. So this is the total number of subarrays that we get. How we are reducing it to a mathematical concept, you want that? So let me recall how we used to do it. Yes, got it. I remember aisa kuch tha. So basically it is like you add n minus 1 with 1, you get n. You add n minus 2 with 2, you get n. You add n minus 3 with 3, you get n. You add n minus 4 with 4, it is like n, right? So there is like multiple ways to derive it. One is, yes, you can use the arithmetic progression formula. So the arithmetic progression formula is something like this. We want to find out the sum of arithmetic series. It is n by 2 into a plus an. Yes, this is this. So it is n by 2, and this is 1 plus first term a plus 1 into n. So it is n by 2 into, so this is the sum of any arithmetic progression. What is the arithmetic progression over here? So this common difference is 1. This is one way. Another way is by observation. You can just check n minus 1 is getting added with 1, n minus 2 is getting added with 2, n minus 3 is getting added with 3, n minus 4 is getting added with 4, so on. So you are going to find out, so this is going to form n, and you are going to form how many n's? So you're actually going to form, I guess, n minus 1 n's using this, right? You're going to form actually n minus 1 or n minus 2 n, something like that. Yes. N minus 1 n's. No, n minus 1 by 2 n's, yes, something like that. Yes, n minus 1 by 2 n, and then you have 1 n from over here. So that is plus 1. So that makes it something like it. So you can do this in this way as well. So basically it is like, you can validate this. So you can add this with this, n by 2 and n minus 2, and you'll get somehow like somewhat like n n's. This will make n by 2 n's, and you already have 1 n, right? So it is n by 2, n into n plus 1 by 2. So these many n's divided by 2. Okay, ऐसा कुछ आता है, ठीक है? So that is also one mathematical induction. Yes. This is yes, this process is actually known as mathematical induction, where you prove it by taking examples for multiple. So you can take example of one size, you can take example of 5 size, you can take example of 10 size, and then you can take example of k size, and you can prove that this holds true for any k size array. Yes. Better use the arithmetic progression formula. That's always better. Okay. Chalo. Now let's talk about why can't we reduce it. Okay, now this is going to be interesting, and there is one observation that I also missed initially, but yeah, it is going to be n cube no matter whatever you do. Just a second. Okay, sorry. Yeah. Okay, now why can't we optimize it? Chalo, let's talk about how can we optimize it. See, so first thing is when you are asked to print something, so this loop is not running any extra time, right? So are we running this loop any extra times? No. Can we find out sum of all the subarrays without going through all the subarrays? No. So are we doing any additional effort? No. Okay. So there can be one thing that you can that can come to your mind, that instead of printing this over here, so because we are getting n cube over here, what we can do is we can store all the index, right? So let's take a 2-dimensional array which is storing I and j. Okay, it's a 2-dimensional array, let's call it as b. Okay, what does this b array store? This b array is like a 2-dimensional array storing 2 values. Okay, so the first value is the start index and the second value is end index. Okay, start index, end index, start index, end index. Okay, so it just stores the start index and end index of all the subarrays. Okay, that is there in our result. So for example, whenever the sum is greater, so you just store this I and j instead of printing this array. Instead of printing this, you'll just store this subarrays and you will done. Let's say 1 to 4 and so on. Okay, now you can write a loop. For example, for int I equals to 0, I is less than b dot length, I plus plus. Okay, one loop, and you can start your j loop from b of I0, that is the first index, and j of j less than equals to b of I1. Okay, that is your second index. This is the starting index and this is the ending index, right? And you are going to do it for every starting and ending index. You are going to print that, and you are going to print as of j, right? Now one thing that might come to your mind, that this is okay, this is order n, this is order n, so like this is going to run the loop on the first. No, we are not going to run it on any other loop. This 2 loops is going to do over here. See, how is 2 loops solving the problem? So here the index that we are going through. So what is this? We are going from 1 to 2, right? So j is starting from 1 to 2. So 1 to 2 is the same. 1 to 2 is the subarray that we want to print, right? So that is our subarray. We are printing the subarray from 3 to 4. This is running from 3 to 4. We are going to print this. It is going to run from this. So let me write this. Okay, it will make it clear. Acha, understood this one. So let me paste this solution and I explain that using additional space. It will look like n square, but it is not. Now, why it is not? That's an interesting question. You get these kind of questions. So let me paste this thing as well. Okay. Achha, everyone understood that part, right? N into n plus 1 by 2, that is the total number of subarrays. Anyone having doubts on that? That is clear? Is that clear? Yes? No? Clear. Okay. Let's take a B array. What I'm telling is B is a 2-dimensional array. Okay. And how many columns which is going to have? 2. Okay, now can you tell me how many rows this array might have? So this array can have like at max total all the subarrays that we have. So this can be stored over here, right? So the total number of subarrays is n into n plus 1 by 2. And this might store all the subarrays, right? In worst case, all the subarrays sum would be greater than this, right? So we can run a loop from t is equals to, we can run a loop from b of ij, let's call it k, this is 0, b of k of 0 is equals to I, b of k of 1 is equals to j, and k plus plus. Okay, done. So we got all. So instead of printing all the subarrays, we stored it. Now, what's the complexity of this loop? This loop's complexity is big of n square, right? This loop's complexity is big of n square. We have just removed that entire loop from here. right? The loop that was actually printing the subarray, we actually removed it and we are storing it. Now this is a constant operation, right? This operation is a constant operation, and so we are finally getting a complexity of n square. In best worst all the cases we are going to get n square, right? Because the if condition is not having a loop, it is having just a constant expression. Now,
Sir,
yeah.
sir, why here we use 2D array, sir?
So we had to store two indexes like I and j. So that's why I used a 2D array. In 1D array, we can't store two indexes at the same position, right? So
Yes,
you
yes.
can either take two multiple arrays, first storing the I and the second as j. And there is like another way where you can store multiple values at the same index, which we have not learned. So that's why 2D array simple. Okay. So for now, whatever we know, this is like the one of the ways to store it. You can have multiple one-dimensional arrays doing it. That is also fine. Okay. Now let's look what we can do from here. So we can just iterate through I equals to 0, I less than k, which is like the index till which we have found the subarrays. That many subarrays we have found, and what we have to print. So j is equals to p of I of 0, and it will go till b of I of 1. Right? So the first index and j plus plus. Okay. Now this is the actual indexes of the A array. So you can do system.out.print A of I, A of j, and you can do plus this. And you can do system.out.println. Now if I run this, you will be seeing the same output that you got earlier. Same result. If I submit this, this will also working fine. Okay, submitted. Okay, now how is this working? Why is this working? What's the logic behind this? Let's check. See, over here, okay, see. So here, what we are doing is instead of now it looks like figure. First of all, let's talk about time. So big of n square plus big of n square. Final complexity is big of n square, but actually it is not. Okay, I'll tell you why it is not. Okay, so now here it is like no, inner loop is not constant. This is not constant. This is not running for a constant value. See, this is not running. See, look at here. What is happening? Look at this carefully. That you'll miss out a lot of things, and it will be difficult to understand. See, this part when we are finding out the sum is greater than n by 2. What we are doing, instead of printing that from earlier, we were running a k loop from I to j. Yes, and we are printing all the values. Instead of doing that, I am telling that let's store this I and j so that we'll print it later. Okay. So we'll print it later. Let's store this I and j. So we took a B array, B loop, B two-dimensional array. This is a 2D array, but like each index just each array just stores two values. Okay. What is these two values? I and j. It just stores I and j, I and j, I and j, whatever values I and j has. So let's say for this particular question, okay, let's say this particular question, what are the subarrays that we are getting? So we are getting the subarray, first subarray that satisfies the condition is 1, 2, 3, that is 0 to 2. So firstly we stored 0 to 2. Okay, then A of 0 is B of 0, 0 is 0, B of 0, 1 is 2. Okay, we increased k, so next time we'll store in the next array, which is where we found this one. So we got B of 0, 3. Okay, next we found B of 1, 2 and B of 1, 3. Then we found out B of 2, 3 and B of 3. So these are all the subarrays that we got in this particular example, and we stored their indexes. Okay, we stored their indexes, that these are the indexes of the subarrays starting and ending index which are having sum greater than n by 2. Okay, now here what we are doing is we are running a loop that is going through this entire please don't annotate. Yeah, and now we are going through this entire loop. Okay, just a second. Let me use a different color here so I can explain. So now we are going through this entire loop. What is this doing? This is going through all the sub-arrays that we have, right? So all the sub-arrays that we have. So this is like going from index. So this is index 1. So B in the B array, right? This is the array at index 1, index 0, index 1, index 2, index 3, index 4, index 5. So I'm writing a K loop, sorry, I loop that runs from all these index 0, 1, 2, which is like all the sub-arrays. How many sub-arrays did we find? K sub-arrays. Every time we find a sub-array, we are increasing K. So we found K sub-arrays. So we are running this loop from 0 to K. Okay. So you have K sub-arrays and we have to just print them. Now inside this loop, what is the index that we are going to have? What is the index of this sub-arrays? What's the start and end index? So the starting index of the first sub-array is B of I 0 to B of I 1. So you're running a loop from 0 to 2. J loop runs from 0 to 2, which is the index of this. We print that sub-array, we get 1, 2, 3. Okay. Next iteration, which I changes to 1. So in first iteration, I was 0. Now it changes to 1. Now find out the second sub-array. So index 1, what is the second sub-array? So second sub-array starting index. So we run the loop from 0 to B of 0, B of 1, 1, which is 3. So we run the loop from 0 to 3. So this is running for actually the sub-array starting index to the sub-array ending index, this loop. Okay, starting index to the sub-array ending index, and we are printing that sub-array. So instead of storing, so how do we store the sub-arrays? We actually store the start and end index, and then we are using to print it. Yes. Okay, understood the logic first. So what we are doing, instead of printing it right away, we store the starting and ending index. Later we are telling, let's go through all the starting and ending index and let's print all the sub-arrays. Okay, so all the starting and ending index that we have, we're just printing them. Okay, look at it once more. So this part understood, how we are getting this B two-dimensional array. Is this clear? What is this B2D array? What does it store? What does it point to? Yes. Anyone having doubts in this B? This is clear, right? So we formed this one. This is fine. Now what we are doing over here, we are starting with I equals to 0. What is I equals to 0? This first sub-array. I equals to 0 means B of 0. So what is B of 0? What did I tell you about two-dimensional array? Two-dimensional array is nothing but combination of multiple one-dimensional arrays. Now this B of 0 is just a sub-array. This B of 0 is a sub-array. This B of 1 is a array. This B of 2 is an array. B of 3 is an array. Those are like independent arrays. Okay. So what I'm telling, that's B of 0, the first array has two values. What are those two values? These two values are, sorry, we have this has, sorry, someone is unmute. I don't have that option to mute everyone. Just give me a second.
Ashwata Das.
Just a second.
This meeting is being recorded.
Taken now, yeah. So I now the host taken down. This can be done. Okay. So actually, it doesn't make me the host sometimes. So I have to go and make myself the host again. Okay. Now let's come back to this question. Oh, I stopped the share, right? So I lost all the annotations. Okay. Okay, so now once we got this B array, what we are trying to do is, so let's say the B array looks like this. First is like 0, 2, 0, 3. So we have this B array which looks like this. Okay. Now, what we want to do with this B sub-array? What we want to do with this B array? So this is just the holding all the starting and ending index of the arrays that we want to print. So we are just going to start with 0, and we are telling, okay, let's look at the 0, which is this, that is the starting index. So J will start from 0 and we'll go to the ending index, that is B of 0, 1, which is 2. So this is the subarray which was the solution. This was a subarray which satisfied the condition. This should have been printed. So we can print it now. Okay, instead of printing it here, we just are printing it in some other way by storing the starting and ending index. That's it. Right. Remember the questions when we did the subarrays, I told you, right? The best way to remember subarray is by storing the start and end index. If you have the start and end index of any part of the array, let's say you have the start index as, let's say, 3 and end index as 7, you can print this array by running a loop from 3 to 7. You don't need to know anything about the array, you don't need to do anything. If you know the start and end index from where to where you have to print, you can print any part of the subarray, any part of the array, right? You just don't need to always run a loop from 0 to n to print the array. You can run a loop from any part starting point to the any ending point, and you can still print that array. That is also fine. Okay, and that's exactly what we are doing over here. We are printing that subarray. Okay, by using this. Now understood? So we are storing the subarrays indexes. We are using them to print it. Done? Clear? Yes. Now the biggest question, is it actually reducing the time? So is it actually reducing the time? Let's check. So this is n square. The first one is n square. Yes, first one is n square. Okay, this is no doubt, right? This is running from 0 to n. This is I to n. There is nothing that we are doing over here. So this is constant operation, right? So big of 1. So this is big of n square. Now, what did I tell you? For if you have some like this, where some time gets added. Now, what's the time complexity of this one? Bottom one. So this can be in worst case order n. Why this can be worst case order n? Because we might have like the starting index as 0, ending index as n, right? Starting index as 0, ending index as n minus 1, 1 to n minus 1, 2 to n minus 1, 3 to n minus 1, 0 to n minus 1. All of them are order n, right? So this has an order n complexity. Now, what's the complexity of this loop? What's the complexity of this one? How many maximum number of subarrays we are going to get? So that we stored it, right? How many subarrays you are going to get? N into n plus 1 by 2. And that is the size of this. That is the number of rows into this. That is n into n plus 1 by 2, right? That is the total number of rows in B array. So this outer loop is actually running in the max worst case till the total number of rows. So this loop is running for n into n plus 1 by 2 in the worst case, which is order of n square. So this outer loop in the worst case is running for order of n square. Inner loop is running for order n. So this is still n cube. Okay. So despite using this additional space, the time complexity is still n cube, because this outer loop is not actually running for order n. This is running for order n square. So for example, if I write a single loop and I write a value from I equals to 1 to I less than n square. So this is a n square loop, right? This is not a order n loop because it is written in one loop. This is a n square loop, plain simple n square loop. Same thing. This is also a plain simple n square loop, because in worst case we are going to have n square subarrays on the order of n square, and that is like the total number of times this loop is going to run. So the total complexity is n cube. Understood? So despite using additional space also, we are getting n cube, which is, so why will we use additional space? So this solution is like not at all required. You can directly print it over here, right? So using additional space, if we are, so what did I tell you? So space and time can be traded. So if you are using additional space, your time should decrease. If you are like removing additional space, your time will increase. Okay, understood this? After this lunch break, start the remaining questions. Okay. Any other doubts here? So in question, so in some question, if interviewers ask us to reduce time, what do you say that? Yes, we can keep it, but yes. So see, space and time, that's traded, right? So in a question where you can use space to reduce time, that's fine, and that's what we do with hash maps, right? So we in hash map is just additional users of space, and we are reducing time using that, right? So that's what we are doing. So most of the questions, when you'll optimize, you'll use additional space to reduce time. Here, by even though we are using additional space, we cannot reduce it given the question that we are printing over here, right? So even if you use additional space, this is not reducing it. It is even making it more complicated and no way is helping us, right? So the better solution was anyways to print the like array over here. Okay, clear? This sounds fine. Okay. So this is it. So this is like all the question. Array subtraction done. Okay, that's great. How many of you did array subtraction? Complete ho gaya? How many of you completed it? So I still feel this were easy, right? This was also easy. This was like Ncube is acceptable, so there was nothing to do over here. I already told you how to print. See, every time you see something like this to print, right? I told you, right? If you are asked to print all the subarrays, there is no way you can optimize it. The optimization can happen if you are not asked to print subarrays. If the same question was given to count all the subarrays, then this could have been optimized. This was an n-square solution, and we could have also thought of if we can get something better, right? If it is a positive array, so I'll tell you how can you. So I'll simply tweak this, and now you all tell me. So let's discuss on this one a few more. Okay. I'll do 2D arrays, few 2D arrays question. I'll do subtraction on this question. So we have an ample time today. So we have more than 1.5 hours, right? Okay. So if I just tweak this question and try to solve this one today, okay. Hint for maximum minima. Today I guess I'll solve it. We'll solve it. Chalo. Let's say this is the array. Okay. I give you one simple thing. So basically what you can do is you need to find out all the subarrays, count of all such subarrays. Okay, you don't have to print the subarrays, you have to print the count where the subarray sum is greater than A of mid. Okay. So what you can do is you just don't need to write this entire loop, this entire thing. You can just do count plus plus. Yes. So what is the time complexity? N square. Can you now better it with n square? Can you do better than n square? And the condition that I'm giving you, the numbers are positive. Okay. So the numbers are given as positive, because for negative numbers it can be done, but you don't know that concept yet. But for positive numbers you can do. So let's say the numbers is given, the entire array is positive. The array is not negative. Array is not having negative numbers. Array is having just positive numbers. Now think, how can you do this? I'll give you the logic you need to do. Similar to cadence, right? Similar to cadence. Think of that. Think it is similar to cadence. Yes, I'll say it similar here, not very much different. Okay, so the question is, you are given an array of positive numbers. Okay, positive numbers. Okay, you don't have negative numbers. So the entire array is just positive number. You have to find out the count of such subarrays whose sum is greater than A of mid, whose sum is greater than A of mid. Take a same thing, the same condition, your sum is greater than A of mid. You have to just print the count of all such subarrays. So one solution is you can simply remove all this logic and you can do a count plus plus. And at the end you can print a count. Yes, so this one is easy, right? We just did it. You don't need to do anything. You just need to do a count plus plus, and your solution is done. Okay, you print the count. But can you do better than n square? That's my question is. Think, and there is a solution better than n square. No additional things required. Just a simple logic that you can think of. Just simply using loops and variables. No additional space. Nothing is required. Just variables can be done. Maybe 2 pointers. Yes. Acha, chalo. So what we are doing in the case of cadence. So if finding out the largest subarray sum. Say the sum used to become less than 0 or a negative number, then we should tell that, okay, let's not take this sum forward. Now, if the entire array is positive, okay, and let's say you found out the sum over here is 6. Okay. Achha, sorry, for greater number. Okay, not for greater, you can't do this for greater. I missed it. Think it in terms of smaller numbers. For greater, it is. So greater it would be n cube. So you just have to count. You have to count, right? So this will be fine. Greater also you can count. You don't have to print it. So let's take it greater. Sorry for that. Okay. Now for greater as well, you just need to find the count. Now tell me, how will you count it? Count kaise karo? And given all the numbers are positive. So see, if you're counting over here and you got the sum as 6, let's say the mid element is 3. Okay, mid element is 3. You got the sum as 6 over here. Okay. Now this sum is greater than this, so 6 is greater than 3. Yes, 6 is greater than this sum is greater. Now can you tell me how many sub-arrays can you make from starting with 1? Do you need to count the other sub-arrays, or you can right away tell how many sub-arrays you need to make from here? So the number of values that's there in the right, I'm not asking the total number of sub-arrays, I'm asking the sub-arrays that will have sum greater than this. So see, if 3 is having the sum greater, so the sum till here is 6. Okay, sum till here was 3, which was not greater than 3. Sum till here is 6. Now these numbers are positive. I told you, right? The entire array is positive. There are no negative numbers. So if you have this as greater number, 6 is greater than 3, and you keep on adding positive numbers to this 6, your sum will be greater than sum will be always greater than this. So let's say this is the index we found out 2. So and this index is 3, 4, 3, 4. This index is 4. So how many total number of sub-arrays you can form? So you can form 4 minus 2 plus 1, which is 3 sub-arrays. So which are these 3 sub-arrays? 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. You add any more numbers to the 8 till the end. If there were 6 numbers, 7 numbers, 10 numbers, 100 numbers were there in this array, and the mid element was 3, right? So you would have got all these sub-arrays without even finding out these sums. Do you need to find out these sums? No, because the array is given as positive, right? So if you add positive numbers to it, the sum is going to be greater, and you just have to check for the greater one, right? So you don't need to find that. Understood? Yes, no?
So,
Yes.
so we can do a small change in the given n square option also.
But
Like,
like add a break if sum is greater.
if the sum is greater or equal, we can count the remaining values of remaining index of j and break the j loop.
That we can optimize, but the complexity would still be n square, because see we are so that is fine. Yeah, that is fine. See, just a second. Okay, see, so what I'm telling here is just that once you find out the sum till here, right? Once you find out the sum till here, the elements to the right of it is positive, right? So you found the sum till here is 6. Now, no matter how large numbers you add to this, the sum is going to be positive. Okay, sum is going to be greater than 3. So not just positive, it's going to be greater than 3, because all the numbers in the array are positive. That I told you, right? The numbers in the array are given as positive. So this sum is 6. Now if you add 4 to another to it, so this is also be going to be greater than this. Now you add 6 plus 4 and you also add 5, that is also be going to be greater than 3. Now no matter how many number you add, right, you just get you're just going to get this, all the sub-array sums are going to be greater than this, right? So instead of finding out this sums, you can simply count how many such sub-arrays you can form. So how many sub-arrays you can form? So let's say this is let's say 3 is the mid element. Okay, assume 3 is the mid element, or 4 is the mid element, whatever it is. Okay, and this is 0, 1, 2, 3, 4, 5. So 5. So how many sub-arrays you can form starting from 1? So this is 5 minus 2 plus 1, right? Here it is 5 minus 2 plus 1, which is 4 sub-arrays. So 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Right? So this is a general logic that you can find. So these many. Yes.
सर ये मैंने चैट में एक इमेज शेयर की है सर, एक बार देखना सर प्लीज.
I'm checking. Let me complete this. ठीक है. So understood this. ये कैसे होगा? हमने find out करा sum, and then we told this is the count. Without finding all the sums, you can actually count it. So what I told you, what's the optimization I gave you? Instead of finding this, you can do one thing over here, right? Instead of doing this count plus, you can do count is equals to count plus whatever is the total number of sub-arrays. This, right? This calculation you can do. Let's call it D, and you can simply break. If the sum becomes greater, you counted all the sub-arrays that you could have started from 1, you can break. You can go to the next iteration, then you will start all the sub-arrays from 1, and you can find out this. Yes, all the sub-arrays starting from 2, you'll find out once the sum becomes greater, you can do this similar count and break. So now you're actually not finding a lot of sub-array sums, and you're breaking in between. Achha, does this logic sounds fair? Thoda optimize kara humne. We optimized a little bit. We're not finding all the sub-array sums. We are doing it. Understood? Doubts on this one? Understood a little bit? Subarray question, simple subarray question, right? Count all the total number of subarrays from 0 to mid, subtracted from
Sir,
total.
sir, then how to change the first index, sir?
So yeah. Yes. So now here, see, when you found out this, so this is n square, right? This is still n square. Why? Because you're running two loops, right? And like, let's say this loop is like always 1, 1, 1. This condition never satisfy. You worst case go till n, right? From 0 to n, 0 to n, you go in that way. Let's say the mid element is the largest element. The mid element, the array is not sorted, right? It is not given sorted. I've just taken it as sorted, but let's assume this is the array. So this is 100, 3, 4. So no matter, like, you'll every time end up finding 1 to n, you'll not find any subarray. From 2 to n, you'll not find any subarray. 3 to n, you'll not find any subarray, because mid is largest than any other element. So this is the worst case. Mid is the largest element. It is larger than the entire array sum. So you'll not end up entering into this if and breaking the loop. You'll end up running this n square times, and at the end you might not even find any such subarray. You'll find one such subarray that includes this, right? With the subarray that includes this, that those will be the subarrays where sum will be greater. Other subarrays which doesn't include this will not be greater. So something like that you'll find, right? Even if you're running till mid, that is n square. Now, acha, everyone understood this? इसमें कोई doubt नहीं, right? You can do it in n square. 4 minus 2 plus 1. Okay. So how many subarrays starting from 1? So this is, let's say, the subarray 1, 2, 3. This is given. How many subarrays you can make by adding more numbers to it to the right? Given these are the numbers you can add. So you can make 1, 2, 3 is one such subarray. You can make 1, 2, 3, 4. You can make 1, 2, 3, 4, 5. And you can make 1, 2, 3, 4, 5, 6. So you can altogether make 4 such subarrays. How did we get 4? Now, how did we get 4? So this index is 5. This is 2. So this is 5 minus 2 plus 1. So that is 4. So that's why this is n, like 5 minus 2 plus 1. In case this 6 is not present, this is still 4. So it is 4 minus 2 plus 1. That is 3 subarrays. 1, 2, 3, 1, 1, 2, 3, 4, 1, 2, 3, 4, 5. These were the 3 subarrays. Understood? Yes. Okay. Now this is clear, right? I know I wrote a lot of mess over here. Okay. Now the last question. Now you all try to figure this out. This is very easy, super easy. You have done it in Cadence. Trust me, you have done it. You can do it. Okay, there is no difficult in this. So here, tell me what I told you in Cadence. Observe the operation that you are doing again and again. So let's say this is the subarray. Okay. Now here we found this. Let's say this is the subarray which is greater, and then I told all the subarrays are going to be greater. Okay. Now acha. Yeah. Okay, see, so now, like what I told you, to find out all the repeated operations, right? Repeated operations find out karne, so that we can reduce it, right? Once you find that repeated operations, your time can get reduced. So see, let's say if you are finding out sum till here, okay, to find out the sum which is greater than mid or something. Next time, when you are running the loop for I equals to 1, what you are doing? You are going to find out sum from here to here. Now, is it not a waste of time to find out this sum? We already knew the sum from 2, 3, 4, and we are again finding it out. So what you could have done easily to avoid finding this sum out? So instead of doing this, just subtract a of 0. Next iteration, when you want to find out the sum from here, so let's say you got this, this sum is holds this sum till here, then subtract this, right? Just remove the start element that you are removing in the next iteration. That's done. You don't need to run this array again. You're just shifting the sums. What some idea? Thoda idea laga. I'll not give you the solution right now. Think today, right? So the question I'm writing out here. Okay. So I'm writing out the question over here, and now think it through. I gave you hints to how you can think, and we'll discuss this. Okay. So this is an interesting question. You can optimize it for order n. So let's say the question is, you are given a array of positive numbers. Okay, this is important. You don't have any negative numbers. Yes, Okay, you take the Sunday as break, right? Take tomorrow you have another Monday, work fresh, right? Go out today. You did well till now, right? So you deserve this weekend, right? So Sundays I say generally I prefer take one day in your week as off. Okay, when I was also preparing, I used to take one day. My day used to be Friday. Okay, so that used to be my day. So I used to take one day as complete off. I won't do any coding. I won't do anything at all. Okay, I just would watch movies. I just would play, right? Why Friday? Because the most hectic day till in the week was from Monday to Friday, going college, maintaining labs, doing all the things. So that's why Friday. Friday used to be my off. Okay. So after coming from college, I used to take the entire off. I did not used to do. Okay. Not the entire day. I'm not talking about the entire day. Just the time. Just if you want some time to relax, go relax that. Take a day. Like if you want Sunday, take Sunday, right? Take some time off for yourself so that you are starting fresh again next week. You're not blocked. Okay. Yeah. No, you deserve, right? You deserve. If you work hard, right? If you're honestly working hard for the remaining 6 days, right? 6.5 days. If you're honestly working half for remaining 6.5 days, then half day is fine, right? Half day you can take off. But if you're honestly not working hard for 6.5 days and you're putting everything for the 7th day, right? So then that is not right. So you have already taken gaps, right? So honestly work hard for 6.5 days and take that break for the next half day. Wait for that half day. Watch the series, right? Whatever series is new, watch that series complete from end to end, 6 hours, 7 hours, whatever it takes, enjoy it, right? But honestly, before doing that, honestly work for 6.5 days. Then only you can justify that break, right? Chalo. So you're given an array of positive numbers, what you have to find out. So, and let's say not the mid, let's say you're given a k, okay? And a k, given an array of integer and a value k. Okay, what is this k? You have to print the count of count of all subarrays whose sum is greater than k. Okay, see, so given an array of positive integers and a value k, take not the mid element, here it was mid element. Chalo, let's take k, which will make it even more interesting. Okay, so you're given a value k, you have to print the count of all subarrays whose sum is greater than k. Take k is also a positive numbers, you can assume, because array is positive. Now you can need to figure it out in order n. Okay, so you can immediately do it in an n square logic, right? And you have to print the count. Yes, the count of all. No, you have to print the count. I mentioned, right? Print the count of subarrays, not subarrays. You don't have to print all the subarrays. Print the count of subarrays. Count of subarrays whose sum is greater than k. Okay, you just have to print the count. At the end, there should be a single number telling that 5 subarrays out of all the subarrays that you can from this array has the value greater than k. And you have to do it in order n, not n square. Okay, n square is easy. Order n, you need to think. Okay, think through it. You can use the example of cadence. Okay, that would be fine. Okay. Okay, I'll share the online GTP link. So this is the link. It has all the question links as well. And this is the question. Now try this. Have your lunch break. Show sharp at 1. Okay. 15 minutes. Okay, 15 minutes is fine. Quickly come back in 15 minutes. I shared the code, right? I shared the link in chat. Okay. Now this one you can try. You have your day, and remaining questions, subtraction, and all the questions we'll discuss today. Okay. So code of contest, yes, it's there. All the contest codes are pasted over here. So you can see the link of the contest questions and the code is there. Okay. So all the contest codes that I submitted, that's working fine. I have pasted the code as well as this. Okay. So take quickly your lunch break, come back, we'll discuss the remaining questions. Hello, everyone. Welcome back. Okay, I think we can start. Okay, let's continue from array subtraction. So let's complete array subtraction. That's like the question like most asked till now. I've been waiting to discuss this. So let's do that. Okay. So let's go to my projects. I already shared this link. You'll be seeing this link in the previous discussion. It will be attached to that. So let's start with this intro to DSAS. This was all. Okay. Okay, so the question that I gave you, try to solve that today. Okay, and meanwhile we discuss these questions. So array subtraction. So what is this? Now we know, like we have all gone through this question again and again. So what we need to do is we need to subtract two arrays, right? So subtract two arrays is similar to subtracting two values. The array represent two numbers. Now, in case of addition, it was easy. It doesn't matter in which order you are adding. Addition of number doesn't cause any problem, right? But subtraction of number does, right? So when you are doing subtraction, you actually need to find out the larger number. So right. So if let's say there are two arrays, 3, 4, 8, and the second array is 4, 2, you can subtract them, right? Because the first array is greater, but you cannot subtract the reverse way around. You cannot subtract these two, right? This from this, because this is not going, there is no way you can subtract a larger value from a smaller one. You can subtract in this way. This is fine. Okay. So now how can you do this? So first, let's take two arrays. Okay, let's take a array which is having the value. Let's take it as 3, 2, 5. And let's take the B array as 4, 9. Okay, let's take this is the B array. So how will you know which array is greater? So let's say first situation can be if A's length is greater, then A array is definitely greater, right? If A array's length is greater in A dot length, and the second is M dot length. If this is the situation, then A array is definitely greater, and you need to subtract the B array from the array as it is. Now, if the second scenario can be N is less than M, which means the B array is greater, right? Third case can be when the lengths are equal, then you have to find out the larger number, right? When the lengths are equal, you have to actually find out the larger number. That will check. Okay. So okay. So when the lengths are actually equal, that will handle separately. Now let's look at these two scenarios. So what we want to do over here, when the first array is greater, so let's try to take two iterators. Let's call it int I equals to starting from the length of the second array. That is n minus 1. Int j is equals to starting from the length of the second array, m minus 1, and int k. Now, what is the size of the result going to be over here? So the result is here going to be maximum between both the arrays length, right? Maximum between n and m, right? In case of sum, the resultant like the result of the both the sums can be maximum between both the lengths plus 1. Here it is just max, right? Max between n and m, that is the maximum length. Okay. Now we can create a result array. So let's not call it a result. Let's call it R, and let's create a result array which is equals to new int, and the size is going to be R. Okay. So we created a new result array, and we'll store the result over here. Then the same I, j, k that we took in addition case, we are just taking 3 variables which will store this difference. Now, what we need to do until there are values in both the arrays, so until I is greater than equals to 0 and j is also greater than equal to 0, until the values are there in both the arrays, we need to do this subtraction. Now, in case of subtraction, like how do we subtract two things? So let's take this current array as example. Let me maximize the screen for a while. Okay. Excuse me. Yeah. So okay, let's take this. So it is 3, 2, 5, and we have this one is 4, 9. Okay. Now when you subtract this with this, so when you're trying to subtract 4 minus 5 minus this will going to get 6. Okay, you're going to get 6. When you subtract this, you're going to get 6 minus 2, which is 8. Sorry. Oh, sorry. Let's do this first step. Yeah. So you're going to get this, but how did you get 6? So actually what you did was you changed this to 15, right? And then you did this. So what we have to do in this case, let's take a borrow, okay, which will store whether we have taken a borrow or not. Okay, so borrow is initially 0. Okay, that means we have not taken any borrow. Now in order to perform the first subtraction, let's say we have to subtract v1, which is a of I, okay, and we have to subtract v2 from it. So we have to do v1 minus v2, which is b of j. Now if v1 is greater than v2, if this v1 is greater than v2, then it is fine. Then your difference is simply, then we find out the difference. Okay, and in difference, okay, now v1 is like first number is this plus borrow, right? You also need to add the borrow. So the previous borrow that you would have taken will get reduced from here, right? You can take the borrow as 1 and you can do minus borrow, or we can take the borrow as a negative 1. Okay, I'll explain why this borrow is adding over here. Okay. Okay, if v1 is greater than v2, then it is fine. You don't need to do anything. So your difference is going to be simply v1 minus v2. Otherwise, if v1 is less than v2, even if it is equal, then also you are fine. If it is greater than or equal to, you are fine. If it is less than, then what you have to do is you have to change v1. v1 is equals to v1 plus 10. You have to add 10 to it. You have to find out the difference, which is v1 minus v2, same thing. Achha. Let's do it in this way. Let's go select the simplicity. v1 less than this. v1 plus equals to v1 plus 10, and borrow equals to -1, and this would be yes. Okay, so I wrote it even in simpler way. You can easily understand v1 minus v2. Okay, check this. So what did I do over here? Need to take the differences for you over here. See, so the two values that we had that we wanted to subtract was a of I and b of j. So we wanted to subtract from a of I, we wanted to subtract b of j. Okay, from look again, we wanted to subtract from a of I, b of j. So a of I is 5 and b of j is 9. So we did a of I plus like a of I, which is 5 plus 0, so which is nothing. Ooh. Sorry, so we have like a of I, b of j, which we want to subtract. A of I was 5, so 5 is we added 0, which is like borrow, we added 0 to it, so that is simply 5. So v1 is 5, v2 is 9. Now see, v1 is 5, v2 is 9. We are checking. एक मिनट वेट करो, फिर से कॉल करेगा वो. Okay, so now this is like 5, this is 9. We are checking, is this less? 5 is less than 9? Yes. So we can't subtract this. 5 cannot subtract 9. There is no way we can't subtract this. So what we need to do is we need to add 10 to it. So what we did, we added 10 to v1. Now, as we added 10, from where did we get this one? We got this one as a borrow from the previous number. So we changed our borrow to -1. Okay. Now, okay. Now in what we did, we got 15. We did 15 minus 9 here. 15 minus 9, we got the difference as 6. Now we need to store this 6 into the result. Okay. So whatever 6 we got, we have to store this into the result. So result of k is equals to this difference that we found out. Okay. Understood this? Acha, how many of you understood this? Okay. Clear? if it fail, if no number is left. So if it does, this is not true, then this will never check, right? So else this will just go to the else part and will make the borrower 0. If this does not satisfy, next iteration will make the borrower 0. Now look, what is going to happen in the next iteration? The first iteration we got 6, that is fine. Next iteration, check over here. Next iteration, when you have 2. So what we did, so next iteration will decrease ing. So I minus minus, j minus minus, k minus minus. Let's do that. Okay. So after we are done with one iteration, you can decrease I, you can decrease j, you can decrease k. Similar to earlier how we did. Now next iteration, I is over here, j is over here. So a of I is this 2. So what we are getting is v1. So v1 is a of I plus. So we are getting a of I. Okay. So v1 we are getting a of I plus borrow. Borrow was -1. We changed the borrow to -1, right? So v1 we are getting 2 plus -1, which is 1. And this we are getting as 4. Now we have to again check, is 1 less than 4? Yes, 1 is less than 4. So what we are doing, we are adding this, we are making as 10. This will change its value to 10, which is fine. We took one borrow, so we changed it to 1, and now it is changing to 10. We again have borrow as -1, so we are again keeping borrow as -1. Here borrow is still -1 because this number also took a borrow from the previous one. Now the difference is v1 minus v2, which is like 10 minus 4, which is 6. We again get 6. We store it in the result, and then we are done. j is exhausted, we are done. Okay. Now I'll handle the other scenario. First tell me, understood this part, how this is working. If let's say this was something like 7, 8 or something, we would have not, okay. Understood this one. Now let's say this situation when this was not this was, let's say, some other value. Okay, let me explain this one. When this is, let's say, 8. Okay, so what would happen in this situation? So first iteration is going to work as same. Next iteration, your v1 is going to be 8 plus -1. So v1 becomes 7. v2 is 4. Okay, you check, is 7 less than 4? No. So you go to the else part, you change the borrow to 0. So the borrow is now changed to 0. So that means we don't need any borrow from the previous number. We are fine with having this number as 7, whatever value we have. Understood? You can do that away as well, Mohammed. That's also fine. So you can take like 5 minus 9, which is -4, and then you can add 10 to it. So that will also give 6. So that is also fine. Okay. Negative number, whatever you get, and you add 10 to it. Okay. Now let's handle the remaining part of the arrays. So like whatever will be left. So for example, if A arrays, which I array is only going to be left, right? J array is not going to be left, because we have already checked n is greater than m. So only I is going to be left. So if I is greater than equals to 0, so what we do, we find out this. So result of k is equals to, let's reduce a few lines. So this we don't need. We can simply just put this difference into here. Let's say, so this will reduce the number of lines. Yeah, rest all are needed. Yeah. So here what we can do is we can simply do a of I plus the borrow. If I plus borrow is equal to 0. I minus k minus minus. Sorry, I minus k minus minus. Okay. Only for the first iteration, if you had any borrow from the previous one, we just add to it. Take a store it in the result. Otherwise, the remaining we don't need any borrow, so we just change it to 0. Okay. So because you'll have only one borrow, you just add -1 to it. It will, okay. There can be one scenario if this is 0, so you cannot have a borrow from here. So it would be 0. So there is one situation over here. So let's copy this. Over 0 over 2. Right, then this way this is removed. V2 is 0. This, okay, this is fine. Right. Now, why did I do it in this way? Okay, I've taken a borrow and this PR is also there. So let's take it as PR. Borrow. Okay, now why did I do it in this way thing? Okay, let's check this whether it is going to be working fine or not. Okay, see. So see for here, right? So what we are doing is, so let's say here, this is like not having any going to give any borrows. We are going to give 7 minus 4, which is 3. But what if this was not this? This was like the previous case, we had 2 over here. Okay, so this is going to get changed to 10. We are going to get 6 over here, and we are still having a borrow as -1. Okay, so that means we took a borrow from here. So what we are doing over here, so we are adding borrow plus borrow -1, which is 2. We check is 2 less than 0. No. So we change the borrow to 0. We just do 2 minus 0. We store the result, which is 2. We do I minus k minus. I is less than 0. We terminate. Yes, fine. We got the solution. Now, what are the other cases? So for example, let's assume if this would be 0. This is 0, 0, and there is 3 over here. This is the number with which you are subtracting. So now what you would get is you got a borrow as -1. So you added -1 to 0, so it became -1. Is -1 less than 0? Yes, this condition is true. So you add 10 to it, so this number becomes 9. Your borrow is still -1, you don't change it. You do 9 minus 0, which is 9. Okay, you decrease 1. So here again, 0 plus -1, which becomes -1. -1, which is less than 0, so you again add 10 to it, so this becomes 9. So this case is also getting handled by this logic. Okay, same logic I just copied. I just removed B and I changed it to 0. Right? Just instead of B of J, I just changed it to 0, and that's it. The same thing I have just copied over here. Understood? All the other things that however it were handling, it handled it. Now this is done, right? We got the entire solution. So this is it, right? Actually now from here it is just copy paste. So what will you do if n is less than m? So you just need to subtract. So like you just need to subtract from instead of a of I, you just need to subtract b of j. So b1 is b of j and v2 is a of I. We just need to subtract b minus a. Okay, that's it. So wherever you have used a array, b array, just change it. So here we have used a. This is b of j, and here it is j. This is j. Okay. So see. So what we are doing over here, in just that we have reversed it. So we are subtracting b of j minus a of I. Okay, b of j is less than this. With same logic we follow. Okay, your v1 is b of j and v2 is a of I. Okay, same logic. We just subtract it, you get the result. Now if the b arrays again has more values, you just do this. Now what else is the meaning? So what you have to do is you have to also add a negative sign to the very first number. Since you are subtracting b minus a, you have to add a negative sign to the very first number. Now how will we add that negative sign? Okay, so let's first try to run this. Okay, let me just try to run this. Enough of this. Like if I don't run it, it will not make any sense. Yeah. So let's try to run this and print this for int I is equal to 0, I less than r, I plus plus. So currently we have the first array is greater than the second one. Okay, this is array. Okay, so we get 276. So this is 6. This is 11 minus 4, which is 7, and this is 2. Okay, which is fine. Okay, I understood this part. I know we have a lot of things to do. We can have leading zeros that we have to remove. We have not added a negative sign that we'll have to add. What if the arrays are equal length? That also we have to check, right? But you tell me these cases are clear. When this is like normal, this situation, when you subtract this, you get this length. And let's just do the reverse, right? Let's take this as A array and this as B array, just the reverse case. So you will get the same value, but you should also get a negative sign in the first number. You get the same result. We are getting the same result here when the same thing is there, but we should get a negative sign. So now let's check how can we add that negative sign. So how will we add that negative sign? Where this negative sign should be added? So the negative sign should be added to the first non-zero number, right? Sorry, someone is saying something. Okay, see, first non-zero number. So how will you find out the first non-zero number? You can simply traverse from start to R. Okay, the first non-zero number that you get will add the negative sign there. Okay, so if result of I, the first numbers can be 0 as well, right? You could have got 0 0 0 0 in the start, and then you could have got numbers at the end, or a single digit number also could be possible. So if this is greater than 0, that means if this is the first non-zero number, we just need to do A of I is equals to -1 into result of I, and we can break. Done. Okay, now if you've done this, you should be able to see negative sign at the first number. Actually, we already have I. So let's take it from here. Let's just take. Okay, so you see -276, which is fine, right? So when you subtract this 325 from 49, you're getting -276. If this is B and this is A, you're going to get it as positive 276. Okay, so you have the borrow situations, everything is getting handled as expected. Now tell me what is the doubts over here. Clear? So just the first logic, you need to understand this one. I just read it.
No.
Yeah.
No, sir, it is okay for, but in case of numbers, what we can do?
In case of
Numbers in the array.
array cells has numbers.
Instead of 3, we take 325. Instead of 2, we can we take
So
an
that won't be asked, right? So if you have an array like that, you can just split it up into a array of digits. Okay, because that would be very complicated, right? Because what you need to do is you need to check for each digit in the array. So for example, for any A of I, you need to do the operation for each digit, because the subtraction will always happen on digits, right? It cannot happen on numbers, right? So best way is to split that array into array of digits, and that's the best thing, like easiest way to do it.
Sir, what about the leading zeros?
I'll talk about that. So leading zeros are very easy to remove. Before that, we have a bigger problem. What if the array size are equal? Okay, so we'll do that. Last while loop. So this one. So see, here we are just seeing this is there here. So let me explain one of them. You'll be easily able to understand the other one. So here, let's say there are more numbers in the first array, which is like obvious case, right? So here we have taken that situation. So this is like more numbers in the first array, and there is like only 2 3 numbers in the second array. Let's say 2 9. So what is going to happen is you're going to firstly subtract this. So this is 13 minus 9, you're going to get 4. Then it is 11 minus 2, you're going to get 9. Then this part, you have to do this subtraction. So you have a borrow as well. So that borrow you have to keep on adding, right? So borrow until this, and just that you assume this second is 0. Just that. I did not change anything in logic. I just assumed that this B of j is 0. And I continued the loop. So in the first loop, whatever we are doing, we are taking this A of I, this was B of j. Just that I changed it to 0. Right? That's fine. Right? It is 0 until, and we run the same logic, and this is how the subtraction works, right? So when you like in childhood, we were also taught to do it in this way. Add the zeros are not there, add zeros and then do it. Later we got used to, without writing zeros, we were able to do this. Same thing we are doing, we are just adding zeros over here. Simple. Understood? Now this negative sign, how does this negative sign come? So let's say you subtracted this. Is this clear? Is this understood? Okay. Yes. So now let's say, why did I add the 0 to the first non-zero number? What can be the situation where these values will be 0? So take an example like this. So take, let's say you are subtracting 99428 and you're subtracting 992. Okay, let's say 421. So this is the number that you're subtracting. So what you're going to get? So you're going to get 7 and there will be a lot of leading zeros. So what's the negative sign? Where should you add? You should add it here. No, there cannot be a negative sign present in front of 0 or something. The negative sign can only be present in front of a non-zero digit. And this will anyways remove, right? So these leading zeros will anyways remove. So this one will remove. So you just need to add the negative sign over here, right? So that's what we are doing. We are finding out the first non-zero digits. We are running a loop from 0 to R. We are finding out the first non-zero digit. So if the digit is greater than 0, that is non-zero. That if it is equal to or less than, it cannot be less than 0. If it is equal to 0, then it's not non-zero. If it is greater than 0, then what we are doing, we're just adding a negative sign to it, minus on this, and then we are breaking. So that's how it will get the negative sign in the first non-zero digit. Understood? Clear? Okay. So this is it, the subtraction logic. Now there are few cases to handle. Okay, let's do that. So what if these arrays are of equal length? Okay. So what if this array is like this, 3, 3, 8. So this is the second array. Now what we need to do is you need to find out which array is greater out of A and B, which array is greater array. So how can we do that? So let's say initially flag is 0, which means both the arrays are equal. Okay. And what was the logic that I gave you? So if both the arrays are having an equal length, so that scenario you need to do this. So int n is equals to m. Okay. In only that situation you have to do this. What you have to do? You can run a loop from I equals to 0 to n or m, any one, both of them are equal, so it doesn't matter. I plus plus. You have to check if A of I is greater than B of I. If this is the situation, then A array is greater. We can put flag as 1. Okay, we can break. Else, if A of I is less than B of J, that means, sorry, B of I, that means B array is greater. We can put flag is equals to 2 and we can break. Okay. If none of this condition satisfies, if let's say they are equal, right? So first iteration they are equal. This also doesn't satisfy. If 3 greater than 3, 3 less than 3, both of them doesn't satisfy. So we don't do anything. Next iteration, 2 greater than 3. No, this is false. We come over here. 2 less than 3. Yes, this is true. So that means B array is greater. Yes, see, B array is greater. Okay. So B number in the B array is greater. Okay. That's why flag is 2. At the end, if you find out flag is 0, what does this mean? This means both the numbers are equal. Now, if you subtract two equal numbers, what is the result that you are going to get? So result you are going to get is simply 0, right? A single 0. So you can return new int 0. You can handle this in separate ways. A new int of one size, right? So if you just create an array of one length and you just return it. So it is 0, 0, 0 in the question that is there in assignment. It has just asked you to print a single 0. So it's like removing all the leading zeros. So I'm just handling that case over here. So in the case of removing leading zeros, I don't have to handle it there. Okay, you can handle it there as well. When you're removing leading zeros, you just have to do it till one less, right? You can remove till one less times. That is also fine. Okay. Now let's say if flag is 1, that means the first array is greater. What do we do when the first array is greater? When the first array is greater, you just need to run the first logic that we already wrote. So if flag is equals to 1, so you just run the first logic. You don't have to change anything else. Okay. So if the first length is greater, that means the first number is greater, or if the lengths are equal and the first array is greater, which you figured out over here, then also will run A minus B. Okay. Otherwise, if flag is 2, that means the second number is greater, we'll do B minus A and we'll add a negative sign to the start of it. That's it. Understood? So you don't need to write any additional logic. We can use the same logic that we are doing A minus B or B minus A, just that we have added flag equals to 1 or flag equals to 2. Okay, there. If this is true, if the number's length is greater, or if flag is 1, that means any one of the situations it is. Okay. And this is or. Okay. If any one of this satisfies, that means the second number is greater or first number is greater. At the end, finally we did everything. Now, like check this one. If the array lengths are equal, then also you'll get the correct result. Let me run it for this. New int 1. Acha, this return, right here we don't need to return it. So here we can print it simple 0 in this situation. Can print a single 0. Let's run this. Okay, so we're getting 0 minus 1 13, so minus 13. Yeah, that's correct, right? So we're getting minus 13. That's the result right over here. Now if you just do the reverse, the first array is greater, let's say 95, and I try to subtract this, so we'll get 4 6 7. This is 7 and this is 8 minus 5. Yeah, so 57. That's fine, right? We have leading zeros that we have to remove. Apart from that, this logic is completely fine. Clear, everyone? How did we handle the equal scenario? And this is the logic, right? So this is a separate question itself. How will you compare two arrays of a given length, whether they are equal or not? Which number is greater or which number is smaller, right? This logic I already also told you. Like you can take a flag and you can run the same logic. Okay, now at the end, finally, now the last thing, removing leading zeros. So how do you do it? So just do this. For let's say, start with I equals to 0, I less than n, I plus plus. Okay. If a question is getting completed by a mistake, then should I always check optimal solution and see, clean codes you will gradually over time you will understand to write clean codes. For now, right, if you're having a solution that's working, that's fine, right? It might be a little bit difficult to explain for now. Okay, like for example, you wrote a solution that is completely fine. You might face a little bit difficulty to explain. See, first of all, if you get a question like this in interview, right? So interviewer is also not expecting to write a very clean solution in the first go, because these are all the edge cases. The interviewer is not expecting, he knows that if you get a solution, you will be able to clean it up, you will be able to write better solutions in it. Now, these are all the edge cases. There are a lot of edge cases. What if a length is greater? What if the lengths are equal, right? So the interviewer is going to look for whether you handled all the cases correctly or not. So if the lengths are equal, you handle them correctly. If the length A is greater, if the length B is greater, then you handle them correctly. How are you adding negation for the first? So is this case handled? So like students might do this as well. So if result of 0 is equal to result of 0 into minus 1 for adding negative sign, right? They'll forget the scenario of the leading zeros. Now this is not going to give you the correct result. This is going to give you wrong, right? So interviewer are going to look for these cases, whether you handled it in this way or you wrote a loop to which is the correct way to handle. Okay. So most of the time, like interviewers are going to bother about this, whether you handled cases rather than clean code. That would be the last consideration, right? To clean up or write a better solution, clean up, you would look for whether you right, used unnecessary thing, wrote unnecessary code. That is the last thing. But first would be to get the solution, okay, and handle the cases. So let's call it as P, which is initially 0, and P would tell me the index of the leading 0. If result of I is greater than 0, then we can store P is equals to I and we can break. Okay, done. So now from P to N, you have all the numbers that's not there. So what is the size of your result 2 going to be? You're going to tell me the size of result 2. So N was the size of the first one. You can do N minus P. I guess it should be fine. N minus P, right? So first array's length was N. You got that P is the index from where non-zeros are starting. So let's say this is index just +1 -1 situation. So let's say this is 0 0 0 and this is 1 3. Okay, your N is 5. P would be 0 1 2 3 0 1 2 3. So P would be over here, which is equals to 3. Yes, so 5 minus 3 2, which is fine, right? So you're getting the correct N minus P. N minus P is going to give you the correct result. Now I just need to run a loop from I is equals to P, I is less than N, I plus plus. Your result 2 of I minus P is going to be result of I. And its length is, let's say result 2 dot length equal to of n. Okay. Now if I run this, see, you can convert an array into number and perform subtraction. That's fine, but the problem that you're going to get is, just a second. So the problem there is, like, if the array length is like 50 or something, no matter whatever, like however large number you try to store, you will not be able to do it. They're getting 57, right? No leading zeros, nothing. Okay, so you're getting the sum result as 2. So if the array is of 50 or 100 size even, you won't be able to convert that into integer or long. That's going to break. So see, why result of 0 is not -0? Because see, here you have a leading 0, right? So when you do result of 0 is equals to -0, that's going to be a problem, because the leading 0 will get the negative sign, which will not do anything, right? Here in this situation, you had a leading 0 that you are removing. So you'll end up adding the negation side to the leading 0, which you are going to remove later. Okay. So that's why we figured out what is the first non-zero digit where we have to remove add the 0. Okay, understood? Clear? Now shall we paste this logic? So let's copy this. And let's finally test it. Untested. Let's go to array 1. This is a very fun question that whoever has put it, this is like very interesting every time to discuss. Let's put this code into production. Yes. A, B. Okay, so why this is B, this is A? Who has named this in this way? So we have to do B minus A then. So let's AR1 and someone even tried to do this. Why people play this tricks? Okay, let's check the logic. So this is the two arrays. Let's paste it over here. Oh, just one thing. We have to remove this. We have to do this. Also, return statement at the end. Return result 2. Now run this. 198, yeah, which is fine. Let's check for this one. 1213. Yes, fine. Okay, let's change this number. Let's just swap the arrays. So you should get -1213. We're getting 2 for this situation. Just a second. So we are doing this is length. So let's check. We should have subtracted B minus A. Okay, so this, let's check from the start what is happening over here. So we're getting a simply 2 over here, which we should not get. So we are subtracting this, and n is greater than m, this doesn't satisfy, we come over here, right? Would you have taken to complete this? So if this question is asked, this is definitely a worth of 30-40 minutes question. Okay, because there are a lot of edge cases. So you would definitely need 30 to 40 minutes to explain it. See, in interviews, no one is like going to run your code in production. That's the first case. Interviewers' point is not to get a production code. His point is able to check whether you are able to code this out, whether you see those cases, whether you have done so much program. If you did so much programming, you will be able to see these cases like this, n equals to n less than m. And that's the entire point of asking this, to check the edge cases, not to write your code in production or check it on lead code whether it's fine or not. Okay, so let's check over here what's going wrong. So this is fine, plus 10 minus 1, so it's 2 1 1 2 3 4. So let's debug over here. Right here it is going to be painful to debug. Let's check over here. So let's check it for this. So it is 2 1. First array is 2 1 and the second array is 1 2. What's the value? So we have 1 2 3 4. What's the subtraction result going to be? It is going to be minus of something. So you see 2. Yes, no, that's a problem. For n less than m, so first this is n less than m. First array's length is less than the second array's length. We go over here, we check, find out this, subtract, borrow. Okay, so let's check. So now we do b minus a, right? So b of j minus a of, so this is 1 2 3 4, and with this is 2 1. So b, this is b array, this is a array, we subtract this. So b of j is going to give me this. Okay, I guess we had made some addition subtraction, and this is j minus minus. Okay, let's check. Should have given us the correct result. I don't know what's going wrong. So this will get as v1, which is 4, right? So v1 is going to v1 we are getting as 4. v2 we will be getting as 2. Okay, so v2 will be getting as 1. Now 4 less than 1, this is false, so we just go to else. Br is 0. Result is 4 minus 1, that is 3. Okay, I minus minus, j minus minus, I come over here, j comes over here, and next iteration we get this as 3, this is 2. So we do 3 minus 2, j is less than 2, so we do this. Okay, this is false, we do br is 0, we just get 1. This loop terminates, j minus minus, j becomes less than 0, so j terminates. We go to the next iteration, 1 3. Now over here, this is fine, so you'll be getting this as 1, this as 2, this is 0, we'll add 2, this is 1. So this I guess we are getting as fine. I guess we have done some mistake over here. This was fine. I guess while removing this we have done some mistake. So if a of I is, result of I is greater than 0, we are storing it. So actually, let's check this. Let me just I'm assuming this is the place where we made a mistake, so let's check this one firstly. Result of length, let's run this. Now we are getting minus 1 1 2 3. Okay, this is fine. So okay, so this is fine, this solution is fine. I guess we have made some mistake over here while writing this logic. So let's check this one. Okay, so p equals to 0, we are getting result of I is greater than equals to 0. If it is greater than 0, we are storing p and we are breaking. So if we are starting from the start, so this is okay, so this should be not equal to 0. So we are getting minus 1 2 y2. If this is not equal to 0, we p of I is equal to this. This should be r, right? The length of this is r, not n. Yeah, okay, fine. So this was the mistake that we checked. So this should be r minus p, and there also we have to run it till r. Okay, so that was r, not p. Okay, n. Okay, that was the mistake that we did. Okay, logic was correct, just we wrote a wrong variable, so that is not n, that is r. Okay, so sorry, this one, right? So where we are calculating the length, that is not n minus p, that is r. Okay, so here its values are not n, this is r. N is the length of first array, right? This is r is the length of the result array. So these loops will run for r, right? Now it's fine. Okay, so now if I run this, you should be able to see minus of this. We still removed one. So this is not equal to 0, right? So because in case of minus, we have already added minus, which is not equals to 0. So which is like not greater than 0, it is not equal to 0. This condition would be fine. Now you submit, it should be fine. You should see correct result. So out of 90 minutes, 40 minutes, I would expect this, if it is a 90 minutes interview, this question would be reserved for 45 minutes. Okay. So see how your interviewers would break you down, right? So if it is 90 minutes interview, right, no interview is going to ask you 3 questions like this. Okay. No interview is going to ask you. There are questions that is going to ask which will only take you 5 minutes to solve, including the writing code part, right? So you just need 5 to 7 minutes to firstly explain your approach in 1 to 2 minutes and then write the code in 3-4 minutes. Okay. And that's like how your first 2 questions or 3 questions, and let's say even if you take 10 minutes on the first question, you took 15 minutes in the second question or 20 minutes, then also you have around 1 hour for the third question, which could be like this, right? Like yesterday's codes, right? Same. So first 2 questions were super easy, right? That pattern blending question was super easy, so you could have saved time there. And then the sub-array question, even if it required optimization, that question incidentally asked you to print it. But even if let's say it was some variation of Cadence where you would have required optimization, so the exam was 90 minutes or 2 hours, whatever it is, then you could have solved the first 15 to 20 minutes or at max 30 minutes, right? So your questions, 3 questions are never going to get divided equally. Like if you do that mistake of dividing 30 minutes, that's very big problem, because the last question is going to be difficult. You cannot solve it in 30 minutes. You require 40 minutes, 45 minutes for that. So the best way is to save time on the initial questions. Okay. And do this calculation back of your mind that if this question is easy, you have done the solution and that is optimal, stick to that. Okay. Tell that this solution is the most optimal one. This is like going to give this complexity. Interviewer might suggest you some alternative ways to do it. You can you don't need to disagree with him. You can say yes, this is also a way, but seeing this, we would also still get a time complexity of this. And if you feel that his code is more cleaner, you can say yes, sir, I guess your code that you're suggesting would be a cleaner approach. Yes, so yeah, that would do a cleaner solution. You can ask, do you want me to write a solution using that? Most of the time interviewer would say no, right? Because he would have got the idea that you did the solution, you handled the edge cases, you got the correct solution. Now, if you want to implement it in separate way, you can anyways do it. So he knows that you don't want to waste his time on either yours. So you would say, let's proceed to the next question, and he would give you the next question. Okay. You need to do optimization you need to do, right? You don't need to go to the next question without optimization. You have to write the optimized code for every question. Just that clean code and optimized code is different. Clean is right. So this is optimized code means the code might give you the same complexity, might be a little difficult to understand. So that is a little bit not cleaner, but that's fine. That's fine. Okay. Sometimes not very clean codes are you will be able to come up in interviews. That's completely fine. So brute force, I'll say don't write it because that's a waste of time. You can state it to the interview that this can be directly done in this way, right? Okay, Shiva, that's great, right? If you got a shorter code and cleaner than this, that's great, right? Do share it with like everyone so others can also see. I guess what else we can do over here? So there is one thing that I can say, which is like, so you can break it into functions instead of looking at this code. In interview, it would be a lot better. You can get this thing inside a function, and you can just return the flag from there. So you can pass A of A and B to that function, and you can just check if the flag is 0, that means A and B are equal. If flag is 1, that means A is greater than B. If flag is 2, that means A is less than B. So this entire logic you can put inside a function, which will make it even more cleaner. Here, this logic you can, this is a repeated logic. So this is code duplication, which you can avoid. So this entire thing you can put in a loop, in a function again, and you can pass A comma B and B comma A. So this is subtraction of A minus B, and that is subtraction of B minus A, which would return you a result array. Okay, result, and here also you're getting a result at the end, right? So if you are doing A minus B or B minus A, you just get the result. If you get A minus B, so this would give you the same thing, and this would give you the same thing. Okay? So this thing can be put inside a function. Okay, understood? So that it would reduce the code. Okay, diagonal printing problem. Did you not get how to optimize it? So a 2D arrays question I'll discuss in the main class tomorrow. So you have time for that. I need only 1 hour for array list. Very interesting discussion. We'll have array list, and then we will discuss 2D this week. So you have 6 more classes. Okay, and we have just sorting strings. For sorting, I need 2 classes. Strings, we need 3, so 5, and 1 classes to complete this array list and 2D discussion, 2D arrays questions. Okay. Okay, so I guess we have done everything. There is no questions that's left from here. Arrays 2 also, I don't think there is any question that you have doubts. Geometric, let's we did. Maximum subarray sum we did. Cadence algorithm, direct question. Maximum subarray sum divisible by k. So this just you have to find out the subarray sums divisible by k. N square logic. That's it. Okay. And 2D arrays question we'll discuss on Monday. Any other doubts? If the geometric progression has more than 3 elements, then like it will be n to the power 4, n to the power 5. Going by the current logic, we can use some data structure to reduce it. And ideally that can be solved by dynamic programming. One way I can see is to use dynamic programming to solve it, where we can store the common ratios. Okay? So that is like a DP question, which you don't need to know now. For now, that's the best solution you can get. Or we can use hash maps as well. That is again something which we can't do now. Okay, so there is optimal solution, but that is using logic like dynamic programming or hash maps. Okay. Understood? Clear? Yes. Doubts? No doubts? No questions? Any questions? Vishnu, you're telling something?
Oh, sorry, sir. I don't see that my bosom.
No, I just saw you had some doubts. No issues. And where we did remove the where we did remove the leading zeros? Yes, at the end. So this is the logic of removing the leading zeros. So what we did, so removing leading zeros, so we cannot delete numbers from the array. We already know that array's size cannot be changed. It is fixed. So we need to create a new array. Okay. The thing is we need to create a new array. Now what's the size of this new array? So the size of this, okay, this is going to be R. Okay, let's apply it over here. This is going to be R. This is R. This is R. Yeah.
Sir, hello.
Yes.
Sir, in case of strings, so what? In case of strings, string array.
String array. What we need to do? We'll understand that in the strings part we have a separate topic for string. So string itself is a topic. That's why you did not see any questions related to strings over here in arrays. Okay. So string arrays question will also be there. Okay.
Okay.
When we returned the new array, we always returned the same array. So no, here we like result 2, the array that we returned was result 2 at the end. Okay, which was this, which we found. Only case where I just did not return this result 2 was when both of them were equal. So I just returned it here, right? Without doing any calculation or any logic. I did not do any subtraction. I simply returned a array of size 1, which is 0. Okay. We returned only one array, right? Converting the array to numbers, so the no interviewers will not allow you to do that approach, Avendra. Right? If the numbers could be subtracted in like converting into number, interview will never ask this question in interview. Simply tell you that assume the array size is 50 or 100. Now that is something which you cannot convert in integer or long. Long can also store, I guess, around till 18 or something digits. So beyond that, you cannot store in long. Yeah, there is big integers which can store up to 32, but beyond that, you cannot store in big integer as well. So there is no data type. If now if let's array is size of 200 or something, that is definitely going to fail. Okay. So this is like actually this is the way we store arrays. This is the way we store large numbers as well. Okay, we store it in form of strings. We store it in form of arrays. Okay. So and the calculations is this is how only we do. When we learn about strings, you'll understand, okay, this is the way to do calculation. String also will be doing the same thing. Just that in case of string, we have like ASCII to handle. Okay, ASCII is the only thing that we need to handle. Apart from that, it's going to be same. Remove the array. We don't have to remove it when we return different arrays. If we have to return a different array when we remove array, we don't have to remove zeros. We have to return a different array. You need to return a different array because we can't remove the 0 from this result array, right? There is no way we can remove zeros from this result array. If you would have asked to print it, then we could have simply printed the values from P to R, right? We do not need to create a new array. We just got that, okay, P is the starting index, which is non-zero, until R, then there is going to be non-zero values, right? So we returned only one array. So this is the only array that we returned, result 2, which is having our result, right? So the result that we got, we just did not return it. We returned the result 2. Okay. So result 2 is the result that we get. Spiral traversal. ठीक है, चलो, I'll give you hints on spiral traversal. Spiral traversal का hint है. See, can you do traverse the first column, first row, last column, last row? Did I tell you that they do? How can you traverse a specific column? Last row, first row, last column. There is also a question to print the boundary traversal. Right? So what is boundary traversal? You need to print the first row, last column, last row, first column. Now it's just that you have to fix something. For example, last row, if you are asked to print, if you are asked to print the last row from left to right, we'll fix the last row, which is n-1, index is fixed, and the column index is changing. How is the column index changing? Column index is changing from 0 to n. Okay. So what if I ask you to do it in reverse way? So your column index is, you are going to vary from m-1 to 0, and you are going to use n-1. 4 separate loops, right? You can use 4 separate loops. First one is going to print the first row, first column, sorry, first row, last column, second row, second last column, so on, right? So you'll get the solution. Now this is one way to print the boundary traversal. You also have a question, I guess, or regarding the boundary traversal. This is the solution for that. Now what will you do in case of spiral? So spiral is just boundary traversal for multiple 2-dimensional arrays. Let's say you print the boundary traversal of the first array, okay, and then you decrease the size of that 2-dimensional array. So this is the boundary traversal of second array. Then you decrease the size of this and you print the boundary traversal of third array. It will work if it is if there is few edge cases. If this is a single row matrix, if this is a single column matrix, that you have to handle. Okay. If the matrix is of a single row, if the matrix is of single column, that thing you have to handle it. Apart from that, it is going to work fine. Okay. Understood? So that is edge case, right? That are the cases that you have to figure out why it is failing. Our logic is correct. Why the logic is failing? Because the matrix size might be something different, which we have not considered. So we consider an ideal matrix which is having 3 cross 3, 4 cross 4. But what is 1 cross 4 or 4 cross 1, such kind of matrix? So handle that situation. That is the only edge case that is going to fail. You're going to get the correct result. Okay. Chalo, try this. We'll discuss this, right? We'll discuss this. For square, for non-square matrix also it is going to work. For non-square, I don't think there is any square non-square cases. Is there? So only non-square case is this. I've pasted the link of GDB in chat. I've already done that. Let me share it again. We'll discuss 2D arrays questions. So tomorrow we'll discuss entire 2D arrays questions. We have the entire day to discuss 2D arrays. We'll complete array list. Okay. 2D arrays question, array list. Okay. Boundary done, spiral not getting idea. Chalo, try it fresh today. Okay. So we're done with all arrays things, everything. Now we are just left with 2D arrays question that we'll discuss in class, and this will take care. Okay. So thank you everyone. Okay, finally got the solution for array subtraction. You're happy? Look at that solution. Try to write better solutions than that. I think yeah, there is definitely better solutions than this. Okay. Thank you everyone. See you all tomorrow. Bye bye. Take care.